In this week's space news, we have updates from South Korean launch provider Innospace. Secondly, Sierra Space, the company behind the Dream Chaser vehicle and a future space station, have partnered with two companies to advance space-based semiconductor manufacturing. In our third news segment, Stoke Space has revealed an updated design for their Nova vehicle. And finally, Spin Launch, a company we haven't covered on this channel before, has secured additional funding for their unique approach of launching satellites into space using a giant slingshot. Okay, let's get started. Innospace updates. Innospace has shared updates via post on X, displaying two photos of the first stage oxidizer tank for their orbital launch vehicle called Hanbit Nano, which has just arrived at their assembly facility in Cheongju, South Korea. Innospace has already proven their capabilities with a successful flight of their smaller suborbital Hanbit TLV. The forthcoming Hanbit Nano will be a two-stage satellite launcher engineered to transport up to 50 kilos of payload to a 500-kilometer sun-synchronous orbit. Its first stage will feature a 15-ton thrust hybrid engine, with a 3-ton thrust engine driving the upper stage. The first launch of the Hanbit Nano is anticipated around mid-2025. Innospace has secured several contracts for this vehicle, with launches planned from 2025 through to 2027. They will conduct these launches from the Brazilian Alcantara Space Center. Additionally, negotiations are ongoing with Norway's Andøya spaceport, which would be ideal for reaching polar orbits and could attract European customers. Innospace is also scouting for launch sites in Asia to better serve regional markets. We'll keep a close watch on this innovative South Korean space startup. Now, let's move on to our second story of the week. Sierra Space finds partner for space-based semiconductor manufacturing. Sierra Space has recently signed deals with two companies to leverage their Dream Chaser vehicle and future space station for microgravity manufacturing support. The companies in question are Astral Materials and SpaceForge Inc., with the latter being a UK-based firm but represented by its US branch in this agreement. Tom Weiss, the chief executive of Sierra Space, said, "At Sierra Space, our mission is to create an LEO economy that benefits life on Earth, and these new agreements bring us one step closer. To create a strong space economy, we must harness microgravity, and to do that, it's important to build relationships with commercial companies that have the top expertise in their respective technological fields. Both Astral Materials and SpaceForge are pioneering early-stage startups focused on developing technologies to manufacture semiconductors in the unique low-gravity environment of space, which promises to produce semiconductors with improved purity and performance. The benefits of semiconductor manufacturing in LEO are clear. Earth's gravitational forces pose substantial barriers to quick, high-yield semiconductor production," concluded a report from a 2023 workshop on semiconductor manufacturing in orbit, led by Jessica Frick, then of Stanford University and now chief executive of Astral Materials. Frick said in the statement about the partnership with Sierra Space, "Our technology utilizes microgravity as a manufacturing tool that can only be accessed in space. This partnership with Sierra Space is a fantastic opportunity that allows us to focus on our strength, microgravity crystal growth." Sierra Space signed two separate agreements with these companies, but both are similar in concept. The agreements specify that these two companies will work with Sierra Space on how to use their company's Dream Chaser vehicle for manufacturing semiconductors, and also how these technologies could be included in commercial space stations. "We're eager to play a key role in advancing the US semiconductor industry," Michelle Fleming, president of SpaceForge Inc. said. "By using space as a unique lab, we aim to produce top-quality semiconductor materials that will significantly benefit US defense, telecommunications, automotive, and other critical infrastructure industries." Sierra Space is not the sole partner for SpaceForge. This startup has also entered into a memorandum of understanding with Voyager Space to explore various space-based manufacturing opportunities. Voyager Space leads the development of the Starlab commercial space station. Okay, let's move on to our third story this week. Stoke Space Nova design updates. Stoke Space has recently refreshed its website, unveiling the latest design updates for their Nova vehicle. Nova is a fully reusable medium launch vehicle engineered for both full and rapid reuse. Stoke Space stands nearly alone in their ambition to recover and reuse the second stage, a task only attempted by SpaceX with their Starship vehicle. Recovering the second stage is particularly challenging because it must achieve high speeds to place satellites into orbit. Bringing it back to Earth requires scrubbing all that orbital velocity, a task made more challenging by the limited fuel reserves left after payload deployment. The new Nova design from Stoke Space boasts impressive performance metrics. In full reusability mode, it can deliver 3,000 kilos to low Earth orbit, while in expendable mode, this capacity increases to 7,000 kilos. For geostationary transfer orbit, it can manage 2,500 kilos, and for trans-lunar injection, it can handle 1,250 kilos. They also mention a capability of 800 kilos to C3, which indicates the mass can be launched to just escape Earth's orbit with zero velocity relative to Earth, essentially coasting away at zero speed. The high performance of the upper stage is enhanced by its use of liquid hydrogen and liquid oxygen as propellants. However, hydrogen's tendency to leak poses a big challenge, and how Stoke Space manages this will be crucial to watch. Initially, Stoke Space aimed to launch Nova in 2025, but given the pioneering technologies involved, like their Aerospike engine and full reusability, a feat yet to be fully achieved even by SpaceX, it seems more realistic that the launch might not occur until 2026 or later. Now, let's move on to our final story of this week. Spin Launch receives more funding. Investors have bought $11.5 million of Spin Launch stock, according to a recent SEC filing. Spin Launch plans to use a hypersonic centrifuge to fling payloads, including complete satellites, into orbit. The amount of acceleration would be enormous, over 10,000 G. The question is how many payloads can survive that kind of acceleration? None, unless they have been ruggedized first. Spin Launch is working on this to demonstrate that satellites can be built that can withstand this launch acceleration. If the company can demonstrate success, it can pave the way to much lower launch costs than using a conventional rocket. This year, the company demonstrated a ruggedized satellite for the first time in one of its centrifuges in collaboration with Portland State University, a previously unreported milestone before putting them in orbit. Founded in 2014, Spin Launch has already constructed a 33-meter centrifuge with a vacuum chamber, capable of accelerating payloads to speeds of up to 5,000 miles per hour. They have conducted suborbital flights since 2021, with 9 tests under their belt. Recent images of Spin Launch executives alongside a Space Force general suggest that the US government might be keen on using this innovative launch technology for their satellites. Okay, that's it for this week. We'll keep you up to date with these companies as they move closer to launching payloads into orbit. Be sure to like and subscribe so you will see our upcoming videos. We make videos every week covering the space industry, with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon!